If you're a fan of astronomy, you probably think you know the story of the first time we discovered a planet outside our solar system. It goes something like this. Once upon a time, long ago, it was 1995. And by observing changes in a star's motion, Swiss astronomers found our very first exoplanet orbiting the star 51 Pegasi. It's an amazing story, but it has just one problem. The planet that came to be known as 51 Pegasi b wasn't the first planet discovered around another star, or the second, or even the third. It just happened to be the first planet we found around a star like our sun. People often forget about the first true exoplanets because they orbit something very different, a pulsar. That's right. Between 1992 and 94, astronomers discovered a whole star system around one of the weirdest objects in the universe. The pulsar in question is PSR B1257+12, which thankfully some astronomers nicknamed Lich. It's about 2,300 light-years from Earth. Like all pulsars, Lich is a special version of a neutron star, an object with a kind of misleading name. They aren't stars in the normal sense because they don't convert hydrogen into helium in their cores. Instead, these objects are actually the leftover cores of other stars. They form when stars more massive than our sun end their lives in powerful supernova explosions, which are some of the most violent events in the universe. As the star explodes outward, its core is compressed under unimaginable pressure. So much pressure, in fact, that the electrons and protons inside its atoms are literally crushed together into neutrons. What's left is basically a ball of solid neutrons about 20 kilometers across. And because that ball is a lot smaller than what the core started as, it also spins a lot faster, just like how a dancer does when they pull in their arms. Lich, for example, makes an entire rotation every 6.22 milliseconds. Most neutron stars have powerful magnetic fields, which can blast out beams of radiation, like radio waves. Depending on the star's orientation, that beam can sweep across Earth like a lighthouse as the star rotates, sending a pulse of radio waves our way. If it does, we call it a pulsar. Timing this beam is how astronomers figure out a pulsar's rotation rate, and they're some of the most accurate clocks in existence. I'm not kidding. Lich's period isn't exactly the 6.22 milliseconds I mentioned earlier. It's actually, well, this. And that incredible precision is how the very first exoplanets were found. In 1992, astronomers studying this recently discovered pulsar noticed something unusual. The timing of this supposedly super accurate clock seemed to be drifting. It was a tiny change, but it was enough to alter the exact distance between Lich and Earth, meaning its pulses sometimes arrived a little early or a little late. And since we can normally rely on a pulsar's timing to be very steady, these changes must have corresponded to stuff around it, tugging on the star and affecting its orbit. By looking for a pattern in the timing variations, astronomers were able to figure out not only that there were planets, 3 of them, but also how massive they were. They started out with some pretty technical names, but they've since been nicknamed Poltergeist, Phobiter, and Drauga, and their masses were one of the real surprises. Not only do 2 of the planets have masses only a few times as much as Earth, but one has a mass similar to our moon. This makes them some of the smallest exoplanets ever detected. But you probably wouldn't want to visit there. All 3 orbit their pulsar at least twice as close as the Earth orbits the sun, which is probably a bad place to be with all those powerful magnetic fields. Actually, if you think about it, it seems like these planets really shouldn't exist at all. They shouldn't have been able to survive the supernova that destroyed their original star. So how'd they do it? Easy. They probably didn't. It's much more likely that they formed after their host star blew up from another star that was also destroyed. Seriously, if you see a star about to blow up, just back away very, very quickly. It gets nasty in there. Many neutron stars also have companion stars in orbit around them, and Lich may have been no exception. Sometimes in systems like this, material from that companion star gets pulled onto the neutron star. It might even be an especially common process for pulsars. Eventually, if enough material gets stolen, the companion star basically disintegrates, forming a disk of debris around around the pulsar. Now, around regular young stars, planets form from disks like this, so it's reasonable to say that that would happen around dying stars too. As far as we can tell, that's likely how Poltergeist and its friends ended up in the universe. Of course, if that all sounds like a pretty unlikely scenario to you, the data would agree. While planets seem to be incredibly common around normal stars, we found them orbiting less than 1% of known pulsars. And that's probably a good thing, because pulsar planets have to be among the universe's most tortured objects. I mean, how many planets are born from a dying star while in orbit around another dying star? It's not exactly a field of daisies. The first exoplanets we ever found might often get overlooked, but studying them can remind us that the universe is rarely what we think it's supposed to be like. From the very beginning, we knew exoplanets were going to be weird, and since the 1990s, we've been proven right over and over again. Thanks for watching this episode of SciShow Space. If you'd like to learn about some of the weird, ridiculous exoplanets we've found since 1992, you can watch our episode about 3 exoplanets with some seriously extreme weather.